So I'm going to look at solving one-step equations. Again, I'm going to break it into the 3 different types that we would be looking at for grade 8, just like I did with the modeling. And similar to the modeling, what I want to make sure that I'm doing is that on the models, I always made sure that I did the same thing to both sides. And I really want to make sure that I'm doing the exact same type of thing when I'm solving it algebraically. So this one says x plus 6 is equal to 15. And so that means I take my variable and I add 6 to it, and I'm going to get the number 15. So I take some number I don't know. When I add 6, I get 15. Hopefully, you can see in your head that it's supposed to be 9. If you can see that, then that's good. Eventually, we're going to get some numbers that are going to be too difficult to solve in our heads. So let's see the process that we're actually using to solve this. So if I'm going to say take some number and add 6 to it, the way that I can undo that is by taking 6 away, right? If you had some amount of money and then I gave you $6 and then I took the $6 back from you, you're going to have the same amount of money you started off with, right? Before I started handing you any money, which I'm never going to do. So if I've got x plus 6, the opposite of that is going to be taking 6 away. And that kind of makes sense from our modeling, right? Because how did we show positive 6? Well, we did it as 6 positive 1s. And how do I cancel 6 positive 1s? Well, with 6 negative 1s. So it's kind of like making my 0 pair. So I've got positive 6, and I'm going to have negative 6 to cancel each other out. And I need to make sure that whatever I do on the left, I do the same thing on the right. I need to treat my equation equally. Both sides want to be treated equally. So I'm going to subtract 6 from the right-hand side as well. Now, the ones on the left, they cancel each other out, and I'm left with just x. And on the right-hand side, 15 minus 6 is simply 9. That's pretty easy to show algebraically how you're doing it. Now, I know you can do it in your head, but I want you to show the steps now so as our numbers get more difficult in grade 9, 10, 11, 12, we can still continue to solve them. Now, we're going to be asked to do this thing called verifying or checking. So if you're asked to verify or check your work, I'm going to look back at my original equation. I had x plus 6 is equal to 15. And we said on our last slide that x should be 9. And what I want to do is I want to make sure that 9 actually is the correct number. So what we do is I'm going to create a chart with the left-hand side of my equation and the right-hand side of my equation. And I'm going to look at the two things separately from one another. So on the left-hand side of my equation, I started with x plus 6. And I say, okay, instead of x being x, I want x to be 9. So I'm going to substitute this value of 9 and take that 9 and put it in for the x instead of the variable x. So remember, when you substitute into an expression, we put it in a set of brackets. And now I have 9 plus 6, and 9 plus 6 is 15. Now that's pretty good because on the right-hand side of my equation, I had 15. So LS stands for the left-hand side of the equal sign, which is just this x plus 6. RS stands for the right-hand side of the equal sign, which is just that 15. Okay? So hopefully you can do most of these in your head, but we want to make sure that we've got the right processes, so as we make it more difficult, we can still find success. So with this one, x minus 3 is equal to negative 8. Well, x minus 3, the opposite of subtracting 3, is adding 3. So I'm going to add 3. And what I do to the left, I have to do to the right. I treat both sides equally. So this gives me x is equal to negative 8 plus 3 gives me negative 5. Okay? And now I need to verify. I'm going to check the left-hand side of my equation and the right-hand side of my equation. The left-hand side of my equation was x minus 3. Now I've said x shouldn't be x should be negative 5. So I have to make sure that negative 5 works. So I'm going to put in negative 5 for x instead. Remember, put it in brackets. Negative 5, take away 3 more. Negative 5 minus 3, or if you need to, you could write it as negative 5 plus negative 3, because it's like taking away 3 is like taking away positive 3 if I throw in a sign. Negative 5 plus negative 3, so that's negative 8. On the right-hand side of the equal sign, we started with -8. We have the same thing on both sides, which means my equal sign is correct. They are supposed to be equal. The left and the right-hand side should be equal to one another. Okay, x plus 5 is equal to 2. The opposite of adding 5 is subtracting 5. So I'm going to take away 5 from both sides. I'm left with x on the left, because these guys cancel, and 2 minus 5. If I had 2 and I took 5 away, I wouldn't have enough, but I would go past 0 and end up at -3. 2 minus 5 gives me that -3. Let's check that we had the right thing. So I'm going to verify. On the left-hand side, I started with x plus 5 originally, and on the right-hand side, I started with 2 originally. Now I've said x. Instead of calling it x, we're going to call it -3. So I'm going to put -3 in. And then I have still plus 5. -3 plus 5 is 2, which is great because that's what I have now on both the left-hand side and the right-hand side. Okay, last one. Here we go. X minus 6 is equal to -2. X minus 6, well, the opposite of subtracting 6 is to add 6. And I'm going to do the same to both sides. When I add 6 to both sides, I'm left with x on the left. And then I've got -2 plus 6, and that gives me +4. We'll just quickly double check that. Okay, so I've got x minus 6 on the left, and on the right we started with -2. Now instead of writing x, I'm going to fill in 4. Okay, and x, if I rewrite it as 4, 4 minus 6 gives me -2. And now I have -2 on both sides of my equal sign, and so we've solved it correctly.